Section 8 in our book, Chapter P, um, involves modeling with equations. And this is the main reason why most of us study mathematics. As little as some of us maybe like story problems, uh, normally the point in studying math is to use it in some way, and that's what story problems are about. Unless you're a pushing the limits of mathematical knowledge, chances are, again, this is what you're going to be doing your math, is using it in situations. So it's certainly worthwhile. Um, I want to use the method in the book to solve problems, and we'll go through a few problems after this in later videos. But here's the method they have in the book. First step, read the problem carefully. And that sounds simple, but I think that's the downfall of many students in solving word problems. They try to rush through and get the idea what they need to do to solve it really quickly. But a lot of times you have to take your time, reread, and figure things out. Then you want to attempt to state the problem in your own words. It certainly will help you test your understanding if you restate it in your own words. In the book, they write it down. In my mind, if you do that mentally, that's sufficient, but I recommend trying to do that as well. Then finally, for the third step, find a variable. They say let x or any variable represent one of the unknown quantities in the problem. And so we'll typically use x. You could use variables that better represent the quantity. That's fine. And I've added this. I also recommend, if at all possible, sketch the situation and label that sketch. That's just as good as a statement that says what a variable represents. So often that's a good substitute to do a sketch and put your variable on the sketch or variables. So, many times, in a lot of the problems we see in the book, there's more than one quantity you're solving for. And this is a good point to represent those other quantities in terms of the variable you've chosen. I know it's also possible, and many of you like to use more than one variable, and so that's possible. But at some point, you're going to have to put them into, at least the problems we're looking at here, with an equation that's in one variable. If you have two variables, for example, normally you need at least two equations to solve that. And if you have three equations, and so on. But you might want to start with more than one variable, but then get to one variable when you do your equation. But I'll stick with this technique here of representing other quantities in the same variable. Third, and this is probably the hardest, understanding how things are related. Take those relationships and express them in an equation. Once you have an equation, now you're just using your algebra, and the fourth step is to solve that equation. And typically you're going to find a value for the variable you chose. That may or may not be the answer. It might be part of the answer. So make sure you go back and make sure that you answer the question that was being asked. Again, this is an area where students often, they find where the variables equal to, boom, they move on to the next thing. But you really need to go back and make sure you've answered the question. And many times it'll be something you need to do that variable, add something to it, multiply, whatever, to find some other numbers. So again, make sure you do that to actually answer the question that's being asked. Then finally, a good idea to check, pick your answer, make sure it makes sense in the context of the problem. If you can do some calculations to check, I would do that as well. I think if you follow 5 steps, it will serve you well in solving the problems we're looking at in this section.